How's it going, everyone? Welcome, Eulio Gonzalez here, exploring observables and why this thing is needed, especially as a UI developer or any software engineer. Because at the end of the day, if you are going to dedicate at least first to be a UI specialist, you quickly realize that a lot of the thing that you have to do is in an event-oriented environment. So you have to wait for events for the users and for the server and for the animations and local storage and so on and so forth. So it is now interesting for us, at least if you are new to this, or even if you have experience with the JavaScript by writing JavaScript code, synchronous and asynchronous. How can we now actually deal with this kind of things? Or in other words, it's like, what do we need to do in order to handle this streams of data? So because this course focus on the asynchronous nature of JavaScript, all right? And we went through, shout out to Kyle Simpson, all right? And we went through, we went to develop a conceptual and practical notions about what is concurrency in our application, the JavaScript application, and understand the subtle difference between concurrency and parallelism, all right? So concurrency is, unlike parallelism, that stands for things that happen at the same time, okay, multiple stuff that happen at the same time. Biology speaking, in your body there is a lot of things that need to happen at once, so you can now stick yourself together, right? However, in contrast with the concurrency, is all of the things that overlaps at a time. There are tasks that overlaps at a time, and how you can handle that. So now the next level of competency as a JavaScript developer is not only to design a front-end system application, which is a good thing, all right, but also to maintain. And another component on designing and maintaining is this concurrency, this asynchronicity. So we went through describing what are the tools that we use to handle that, and they are not native to JavaScript. So for example, like callback, they are web platform dependent. Or they are web dependent platform or environment dependent platform, whether it's for the web or the server. The thing here is, now with callbacks, we have our first approach with callbacks to actually see that at the end of the day, we need to coordinate all of this response. So that's the main problem of this is coordination, right? We look at how can we do that with callbacks, what actually callbacks mean, which is the continuation of this program at some point in the future by passing now a callback, so using the set timeout. And when you want to trigger now several functions, when you want to do is several Ajax requests in parallel. Remember, I say quote quote because even though you can describe that one line after the another, they are executed synchronously because JavaScript works that way. So because now this JavaScript engine, right? When we write our JavaScript applications, this is our programs that's when we talk about process and threads. They are programs that run in a process that has its own resource, okay? And those programs with their own resource are run in this particular process, and those processes they can communicate each other. And the way they do that is by some of this IPC or this inter-process protocol. It can be via a pipe, which is unidirectional. It can be via sockets. So, for example, this two bidirectional data, whether it is Unix sockets or WebSocket, TCP sockets. It also is through shared memory, all right, like a dashboard. Also for a message queue. So this is pretty much like a post service. So web worker actually now is a way of how you can share a message or share data across these different processes that are running. And the others are signals, which is emergency calls. But in any case, because after we went through the callbacks and some of the drawback, which is not exclusively the callback hell, it is most likely the problems that it generate, not only in terms of describing is or how do we have to manage our own concurrency and have to coordinate that, especially if you're firing up several Ajax requests, okay, and then you need to wait for them to come back. Time, you also need to handle the response as they came in, and then coordinate this response appropriately, so you can show them in the proper order where they were called. So this is not an easy stuff. We also look at how can we do that with callbacks just for a single plain or static exercise, and there is a huge things there. And now, why, for example, in JavaScript, we have this concept of thongs, which is something that way predate JavaScript. Some other people in the field, they have the same problem, and they come up with some patterns where they say, hey, because one of the complex factors of dealing with asynchronicity is time. So let's go to now abstract time or eliminate time as a complexing factor to this. So thongs at the end of the day is just function that wrap another functions that have everything that it needs. So by the time you call it, you always get the same value, right? So they act like a token of that. This is for the synchronous perspective. It's more interesting for the asynchronous perspective because now this is the same function, but except that you're gonna pass a callback that everything that it needs. So by the time that data is available, you can have access to that data through the callback. That's great. That's also interesting. And that's now the foundation of Redux libraries, where they don't have any native way of handling this or this to eliminate time as a complexing factor, especially on middlewares, where in the Redux, middlewares is the way of, they are usually used to perform some Ajax requests, because now middleware sits between your actions, and in this context, middleware sits between your actions and the reducer in the context of Redux. So here is when you can say, all right, let's go to now make this Ajax request or this computation that will take X amount of time to complete. And once that is done, all right, let's go to update that state. You know, that's very interesting and fascinating, because that lead us is to move on to other ways of how can we now is dealing with asynchronicity. And why is this? Because at the end of the day, Thong, despite that it's solved the problem of time as a complexing factor, it doesn't give us the trust that we need that, because anytime we pass a callback to somebody, or in this case to this function, you assume that this function won't get triggered too many times, or don't fire too often, too late, don't fire up too many times, too few times, too early, too late. Don't swallow up errors. Don't or don't lose context data. So now promise say, all right, let me now give it to you the trust that we lack with thunks or anytime you use callbacks. Let me give it to you, because promise is the idea of that we need a placeholder that eliminate time as a complexing factor wrapping around a value. In other words, it is like a callback manager. It is like an event listener that you can subscribe to that. So by the time that data is done, you can subscribe to the .ding, and not only that, you can define as a flow control to this promise, which is a great thing. And define the data flow as well. That's why we're starting to see in promise now concepts like monads, because at the end of the day, a promise which comes from the programming language called E, which was created by Mark Miller, one of the TC39 commit member, where they have something called future values. And here in JavaScript, we have something kind of close to that. That it is, hey, now that we have this promise stuff, all right, we can now subscribe to that, and then define is the flow control and the data flow replication. So this promise stuff comes from the functional programmers, which is known as the monad, all right? And I'm just going to describe that in terms of its functionality, right? So monad, it is now used as an state, it's a way to model state change, right? So that's when we need to then go down to that path of the light JavaScript. And I think this is quite important segue, all right? Because the principle, the philosophy behind Redux is that not only make the state management easy to maintain, all right, as a top priority, but also follow the Flux architecture to do that. And anytime you want to update your state, keep separate from any asynchronous logic, right? While now providing you is a global state of to define is all of this different state that you need to provide all of this states followed by the reducers per so at the top of this. So this is the goal, and the principle behind that, or the intention behind that, is that you're going to show to the user slowly what is the architecture that we're using behind the scenes, which is the Flux architecture, why we're using that, and explain or to describe what is this Flux architecture, this action, dispatcher, and the state, and also the way of how you can use the state or your reducer functions by now introducing is a concept like immutability and immutability and serializations. And these particular concepts which is now open up the door of the functional programming. So things like function purity, things like so things like things like function purity, things like function purity or point free arguments. Did I lose my mind? The list operations, whether it's map, filters, and all of that kind of stuff, and then how those operations, how you can apply to a specific data structure, all right? Not only to collections, but also to any other data structures. And then now open up the door of monads. And the idea here is that slowly but progressively, getting yourself into these concepts and understand why we use them. And of course, to make the Redux API minimal, lightweight as possible, and extensible. So make it also is maintainable as a top priority. So because I described this in the case of promises, that this is a monad, right? And now how the synchronicity having its foundation from the functional programming, aka the mathematics. So with promise, we have now this guarantee and also all of these abstractions that allow us to, for example, deal with most common use cases. So for example, hey, I want you to pass now, I want to fire up a collections of promises or Ajax requests, and then I want to know is if all of them was resolved, all right? If it's not, if any of them was rejected, hey, reject this promise. That's where we have the any. If we have all settled, we say, all right, now if any of the promise, I don't care if the promise was resolved or rejected. I just want to just give me is the settled promise, right? And this is give you much more fine control, useful for doing rollback operations. So the other is .any, where it say, hey, give me the first promise that was rejected. So for example, like any. So any like this, all right? It's useful for returning the first promise that fulfill. Okay, so give me is the first promise that fulfill, and then short circuit, right? It short circuit after the promise fulfill, so it does not wait for the other promise to complete once it finds one, right? And the other is the promise the raise. Hey, give me is the first promise that was resolved. Okay, the first promise. Okay, promise resolved with the first promise fulfill. All right. This in contracts, even if a promise rejects first. Exactly. So, give me the promise fulfills when the first promise to fulfill, even if a promise rejects. So, give me is the first promise that was settled, whether it's fulfilled or rejected. This is on any. This in contrast with Ray is say, hey, fulfill or reject with the first promise to settle. Oh, okay, interesting. Okay, fulfills with the first promise. Okay, fulfill with the first promise to fulfill, or even rejects it. Okay, so fulfill whenever the promise is fulfilled or rejected, and Ray say, hey, fulfill or reject with the first promise to settle. In any case, it can be rejected on first. So in any case, and that's why we look at now and ask ourselves a question: what happens when we need to handle these or events? Okay, when the source of data now send off a recurring data flow, right? Or streams of data, which is, of course, the case of UI development, right? As a UI specialist, you're gonna handle a lot with that, right? So can Promise help us here? All right. And before going into that, we went through describing its generators and how now generators is this particular way of describing. This is a syntactic form of describing is a state machine, which is a fancy word to say, hey, a way to model a pattern of series of flows from one state to another, to another, to another, and descriptively lays out all the transactions out, right? So it means that with these generators, we have now the ability to pretty much like you go in YouTube, you want to watch a particular any YouTube video of cats, and then you now click there on play. You can see is all of these little cats actually dancing around it in a very joyful way, and then you pause that, right? And you go back. Let's say you hit the bathroom, and that image will be waved after you come back and resume. So this is similar of what happening is on generators. So here in generators, because now functions run to completion, one of the features of functions, which makes them, this is a very important feature of function. Since now, we are going to, this gives us certainty of our code. That doesn't mean that our code won't run anything else. It means that our code, we're going to evaluate all of this statement until completion if along those functions or in the function execution context, there is now a function call. It's going to now add that to the call stack as a way to know at which line the code base is currently evaluating. So with this run to completion, now generators say, no, we don't want to do that. In fact, we're gonna give you the ability to now pause and resume the execution of this function flow control. And that is huge because here, no one in a function, you can preemptively run a computation when you are in a function. So that gives us now this sense of predictability. But with generator, we don't have that, right? And you may wonder, why do we in the earth, we need that kind of pattern and that kind of tool, right? Because this is a way of how can we describe this state machine. We can do that using iterators and callbacks. And for those who are not familiar with iterators, this is just a pattern to stepping through typically a data set, okay? And because doing this state machines requires a lot of work, right? Because now you have to define is a closure and then the counter, and then count now is at which line of the code you are, and then store and save that data at some point. So you actually need to handle all of this coordination. You have to define this careful programming So now generators say, no, 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 let me actually do that for you. I'm gonna give you now, anytime you define this set of instructions here with the yield keyword, when you run this generator function, gonna provide you an iterator. So with this, it will give you now the control of the execution of that function, or in this case, these generators. So anytime you want to get into a generator, so you run or you call that iterator that is going to control that with the .next. You get in until you find the yield keyword, pause the execution, and then pass control to whoever calls that, right? And then resume. Pause, pass control, and then resume that at some point. This is how you describe this: is pause and resume, pause and resume, pause and resume. Now, why is this important? Okay, why do we need this tool in our language, right? One feature is to actually, well, as the name suggests, generate series of values. All right, pretty straightforward. Okay. And the other is that when it comes to define is the asynchronous nature, okay, to look like synchronous, which is one of the problems that we have with promise, that hey, even though our code now look like much more aligned to in terms of hey, this is the data flow, and this is the flow control of our execution. But we also have is this non-local, non-sequential reasoning. Why is that? Because after all, you can now pass events, or you can pass its callbacks to this, and those callbacks can be in another file, right? And those files can also call another files, and so on and so on. So you quickly realize that, hey, by the time I get this stuff, I want to now handle this two other stuff, and this another stuff is going to now run on this to another stuff, and then this I'm going to save this, and then you quickly realize that, well, this is quite a nightmare to deal with, especially to read about that. So now that's the value proposition of async in a way, or in this case with the generators, right? Using now promise for that. This was a very interesting exercise to do, and yeah, that was very, very interesting. That was lovely. That was lovely. Even though I can recreate that, because to me it was very, very, very interesting. Okay, since now this is the next level of competency of JavaScript developers, by saying, hey, since we wanted to make our asynchronous nature to look synchronous with generators, that now it allows to describe this state machine, or in other words, is to enter to execution of a function, pause it, a pass control, and at some point resume that again until we find a new yield keyword, pause it, freeze everything, and then pass control. Generators not only work as a way to get in and get out of the function, okay? So pause and resume, pause and resume, but also you can pass message too. It provides this message passaging. So, for example, if we want to now say, hey, what is the Pokemon API? I think it is. Exactly. Let's go to fetch now this particular data. You gotta be kidding me, man. You gotta be kidding me, man. Anyways, since we wanted to define is, let's say, this is our code. Say, hey, function here, function fetch data, right? All right, and this fetch data here, you can define here as something like this, because this is how you're gonna create your flow. Create flow. All right. So anytime you now find this async operation, whether it's fetch, okay, and fetch me this data, I want you to now pass control to whoever it is, okay, to whoever controls that, and by the time that now we can is get that data, all right, because here we're going to receive is a promise, okay. Here what it's saying is like, hey, I'm going to now return a promise, and by the time that that data is available, once we get here again, we want is to now is pass the value and store that as our response in this case, right? So what you can do here is say, hey, all right, look at this. Yeah, look at this, right? Since anytime we run our iterator, which is, let's go to now have this iterator here, okay? Create flow, all right? With this iterator, now we have control about the function execution, or the function control execution of this generator, and we say, hey, the first time we get access to this function, all right, since it's going to return us now a promise as the value, well, I want you to now store that here as a promise or as a future data, and then evaluate that. You say future data here. You say, hey, by the time that that data is done, all right, well, please now do this, which is this is the data, and I want to pass that data iterator.next to the function execution. So here we will able to see is now the response object. Oh, there's some missing, really? Future data.next, iterator.next with the data. Create flow. That's right. Before parameter, syntax error missing in line 1. Oh, of course, because it's this, it's like that. And as you can see, we actually get that data immediately, right? Of course, now we need to actually parse that data, right? So if you want to now parse the data, let's go to get the data as it is. You say, all right, well, I want to now is parse this data because I received this as a raw binary data, right? First I received the headers and then the binary data in the background. So I want to make it this data usable in JavaScript. And then we say, hey, all right, well, I want to now is wait for the data to be low, so I'm gonna return the data, or I'm gonna produce that data, and by the time that that data is solved with this promise, I want to now store that data here in this generator. and then show the proper data as expected. So how can we do this? Well, because we are now subscribing to this promise, and promise is this place is the idea around is the idea that we need a placeholder that eliminates time as a complexing factor, wrapping around a value. We can now use the same promise here, the initial promise here, and then now define is this flow control and data flow here. So initially it will be, in this case we can say is a response, say response, okay? Because here we're saying, hey, I want you to pass control to when this function was run, okay? Whoever called me that, it say, all right, and because now I'm passing is a promise here, all right? We say, okay, let's now is, by the time that you are now passing is this promise, and we are returning is a promise here, and this is now how you can actually is change this promise. Well, it's going to now process that here. So here you receive is now this promise. The promise, the future data promise, receive that promise and say, okay, now once that is done, once that instruction is done, I'm going to provide you now the proper data, if that is resolved. If not, you can define as a catch here. But because this is the happy path, we say, hey, now that we get that, after we transform it into a JSON, okay, I'm going to now is pass this data as it is, right? And this is pretty fucked up, bro. Spending full. Oh, because that's right. We need to pass is the response.json, promise of pending done. Okay, I'm here and passing is the response.json as a promise here. Because it returned me is a promise here. So this is the response initially, okay? And we pass this response to this. So the value of this response is now this. So we store this, right? So this response has a JSON methods for that to actually transform that. So by the time it's now evaluating is this, is say, hey, I want to yield this response.json as a promise, okay, which is going to now pass down to this, all right? Oh, exactly, dot value, that's right, exactly, it's going to receive that as a promise, and then is when it's going, exactly, and then, because now here is when you have the promised value, is going to evaluate this, and we just only is now get into the function here, the generator function. So this will work, and there you get it. That's wild, my friends. That's wild. Because this now, we have now this mental model of how can we create this silly example with an async and await function to do that. And if you truly want to test a senior engineer, but a truly senior engineer, this is now the next level of competency for that. Hey, do you know how these things work? Do you truly know how these things work? Especially for handling the concurrency. Absolutely, absolutely. So that was very interesting. And as we move on to understand that the generator and now what is the value proposition of generator, what is the problem that it solves, which is this non-sequential, non-local reasoning, okay? Then, as I mentioned before, because we are handling this with events, the question is that how do we now, or what we need to do to, what we need to do to handle, to process, what we need to do to process is data that comes as a stream from a source, right? So can promise help us here? Yesterday we looked at a particular example here to do that. That was quite interesting. We went to describe it also is how can we is define a button here, and then inside of this button we wrap them into a promise. So by the time that now or we set up the promise around the button, and by the time that now the button emit or the someone click on that button, we're going to emit some random values here, in this case the class name, and that was very illustrative because we went through over the process of the event, all right? The event, the flow events control, which is the capturing the target and then event bubbling. And why do we have this event bubbling? One of them is to reduce the memory footprint that you need to attach an event listener for all of the elements here. And with the capture, we have now a structured way of knowing what is the element that triggered that. So, exactly. So, why do we have an event flow? It's because it's a structured way for overlapping events, control over event processing, which is this. That's one of the reasons why we have this event flow control. So control over event processing and capture and bubble, and the flexibility where events can be handled in the DOM hierarchy. So that's why we look at that the event is now its own particularly objects that you can have from there is, for example, UI events. Most common UI events are mouse, wheel, keyword, input, and then that you have in this context we want to check is a click. We have now the pointers events, and again that was a quick recap of now the event flows works. One, why do we need to have them? And the other is in our context here, how can we now capture series of flows, or in this case capture a series of streams of events, right? And then work on top of that. So because of this, right, since promise only works once, so promise fires once, promise resolve once. So we can just wrap them into its own things here. So we can say, hey, let's go to wrap this promise inside of the event handler, and therefore it's now anytime we listen to that, so do that. But the question is that why do we need to have this? Because at the end of the day, what we really care about is to now not only have a place of the setup, but also it's a place to consume that. And here we are now conflated is these two approach, the promise, the setup, and the consumption. And all of a sudden, that you realize that hey, if you want to get out of this promise from here, you need to do a lot of hoops to get out of this by defining it's a closure state where you're gonna save the state of this promise and then expose that, and all suddenly you begin from. So we are all at the beginning. All of a sudden we are all at the beginning. Now, that's not interesting, not at all, not at all. And how can we do that? Well, there is another particular approach, which is using the context of lists, all right? That say, hey, we can define now as a list, a series of lists, or a series of transformation, all right? To, well, listen to that event and then do something that we need to. So anytime we listen to this particular event, we're going to now is map to that, right? Or apply some sort of transformation. However, the problem remains here, which is we have the setup and the consumption in the same spot, right? So promise by itself are not a good promise by itself are not going to model well in an event-oriented world. In an event-oriented world. So promises are great for waiting for a value only once, all right, but not for handling as streams of data. So promises here are not going to help us here, so we can get rid of them and go with something that is more familiar, which is the list context. However, as I mentioned before, we still have in this particular case is the setup and the consumption in the same spot. And what happens when we need to actually decouple that, all right? Then we have to do all of this nasty stuff, and then we suddenly are where we start. Now, for that, okay, because we want to have the ability to set up and consume chunks of data from our source, enter observables. And here we are. Okay.
Enter observables. Now, understand that observables are not a guarantee for JavaScript. Right now, they are implemented in user-land libraries, and there is a proposal for observables to land in the language. At some point, there was a strong feeling like they might land in the ES7 timeframe. As far as I'm aware, I don't think that's actually going to happen in ES7.
Observables in EX 2024. Wait, what? Well, so why do you recommend me? You think you're funny? Discussion of why Angular will not survive. Anyway. Observables. Oh, exactly. The proposal from observables. Proposal observable. That was 5 years ago. ECMAScript observables. This proposal introduced an observable type to the ECMAScript standard library. The observable type can be used to model push-based data sourced from a done event, time intervals, and socket. In addition, observables are compositional. Observables can be composed with high-order combinators and lazy. Observables do not start a meeting until an observer has subscribed. This is observing keyword events. Okay, this is the proposal here. Using the observable construction, we can create a function which returns an observable string of events for an arbitrary DOM elements and event type, like this. This is the function listen. So you're going to return a new observable that say, hey, this is the observer. We are passing now is a callback here that you want is to now observe this next event from the element, from that element.event listener, attach the event listener to that, and then return a cleanup function which will cancel the event stream like this. All right. So this is now the proposal here. So command key inputs element.subscribe, and if you have the next value or error or complete, we're passing out an object here that contains several callbacks. And the motivation here. Implementation RxG, RX5, CoreJS, send observables, fade observables. This is quite interesting. Absolutely. This is quite interesting. And the proposal, I don't know where is the state of this proposal. Oh, that was in 2017. Okay. We might have this in. Okay. This is a proposal, stage 1 draft. No, man, this will take 10 years more. This will take 10 years more. So that's why we have to go is with Core or CoreJS. That's interesting. CoreJS will allow you to define is this observables. That's pretty wild, bro. With CoreJS standard library. I highly recommend reading this. So what's next? Because this CoreJS, damn son. Modular standard library for JavaScript include polyfill for ECMAScript up 2024, promises, symbols, collections, iterators, type arrays, many other features, ECMAScript proposals, some cross-platforms, and okay, ECMAScript proposals, bro. God damn it, man. Even front master is pushing that. Okay, example of usage. So import CoreJS actual, and then that allow you to do all of this kind of stuff. Look at this. You can define your own generator function here. While true, do this. Drop to take, filter, map to array. You can load only required features, promise set iterators array from flat map structure clone. Interesting. Or use without glow space. That's it. That's okay. I get it. Why this is so powerful. I get it. Why this is so powerful, bro. Promise with resolvers, async iterators. I get it. Why this is so. Finish it proposals. Stage 3 proposals. Parse, float, regular escaping, mass supersize, proposals, iterator sequencing, async iterators, map, stage 1 observables. Interesting. Function prototype, demethodize, is callable and reflects metadata. Web standard, self structure clone. And points that to there. Exactly, they are different. They have different referencing memory. Okay. Circular, circular, circular. Clone dot circular is equal to clone. Okay, they have the same referencing memory. Okay, they have the same referencing memory. Anyway, that makes a lot of sense when we need to use this core GS and all that kind of stuff. So some random guy here actually is working on this. That's quite interesting. On an entire library that, god damn it. On an entire library. Yep, on an entire library. Damn, so man, I get him, bro. Goldie roll query, man. Yep. Yeah, of course. Anyway, Hmm. Oh my God, I get it. It makes a lot of sense. Anyway, all right. Okay. That's quite interesting. That's okay. Okay. Hmm. That makes a lot of sense. In the case, it all boils down to this. So let's go. Let's move on to observables.
Meaning ES 2016. Um, Because as far as I'm aware, as of today, I think the feature cutoff for ES 2016 is like next month. So observables are on a good path, and there's a pretty good chance we're going to get something like this natively in the language. It just might not be next month. So it might be a little bit further off. And that means that what we're about to learn with observables, we're learning based upon the semantics of a particular library implementation. We don't have a very good sense of exactly what they're going to be from a native primitive perspective like we did with promises. So the caveat here is the sorts of stuff that we're about to talk about is subject to some flux. It's subject to some evolution between.
So here we are going to see is a library that might follow the spec of observables in the long run. For example, Redux GS.
Now in the time that some final standard lands, observables may end up being called something different. They might have a different looking API. Who knows? But right now, there's a pretty good library out there for observables, and it's called RxJS. That's our JavaScript library. It's actually, Rx is the name of the library, Reactive Extensions. It's made by the folks, really smart folks at Microsoft, and they've ported it to like a dozen or a couple dozen different languages. So,
so it is made by a real smart folks at Microsoft, and they ported it to several languages.
So RxJS is the JavaScript port. It's in C#. I think that's the original one. It's in Java. It's in several other languages. So it's nice from the consistency perspective. Whatever language.
In C#. Yeah, and it is nice for the consistency perspective.
Language you work in, there's probably an Rx library for it. Once you learn it once, you're going to be able to use it in lots of places. That's good. But
so this consistency is a good thing because you can learn it and apply it in all of this. So you learn exactly. You learn once, and run everywhere, right?
understand what an observable is, again, from a conceptual perspective. See how this is how I always teach. I'm not going to teach you the API first. I want to teach you the conceptuals. So let's talk about spreadsheets. Everybody loves spreadsheets, right? I just found some random spreadsheet image on Google Images because I didn't have any good ones to take of my own. I don't know what this spreadsheet is, but it's pretty clear that this spreadsheet is illustrating the concept that I want to get across. By the way, this metaphor is not unique to me, so I've heard this from others. I just think it's a particularly good one to start with. An observable is kind of like a chain of calculated fields in a spreadsheet. So, you know, in spreadsheets, you can have data in a field, but you can also have a field which is a calculated field. It's calculated based upon the data that's in some other field. So C1 might have the number 10 in it, and C2, right below it, might be whatever value is in there times 2. So when I type in 10, then as soon as I hit enter, immediately this field says 20. And I might have another field over here. I might have D13 that says D13 is the calculation of 3 times whatever's in C2. So I change this to 20. C1 becomes 20, C2 becomes 40, and D13 becomes 120, right? Do you see that the calculation chain is a flow of data? We're setting up a flow of data from an original source location to all these different places where we're doing something with that data, we're calculating something, we're subscribing to and responding to that data. That's the genesis of this notion of reactive programming. When we think about reactive programming, it is to say, the source of my data is some event source. But the data, once I get that event, it's going to go through a series of steps, and some of those steps are going to be direct, like responsive, just calculate something, and some of them might be asynchronous steps. The calculation of the data that goes through the spreadsheet as you change one value, even though it looks immediate to us, each step it has to update all the fields and then update all the fields and then update all the fields. So there is some propagation delay, if you will. But we can think about an observable, or rather reactive programming, as a way to model a piece of data coming in one side, that's from the producer, the event emitter, if you will, coming in one side, and all the steps that it takes to propagate its way through a system. It's a data flow mechanism. And data flow mechanisms are built from the ground up to respond to events. So if we've got event-oriented systems, this might be a really good abstraction for us. Does everybody follow where I'm coming from conceptually? So let me boil this down for you. An observable is an adapter hooked on to an event source that produces a promise every time a new event comes through. Is an adapter hooked on to an event source that produces a promise every time a new event comes through. But it does so in that separate way where I can set up my event source, and an entirely different part of my location, I can declaratively say what's my data flow. I don't have to conflate the two like we were doing in those other examples where I put the promise inside of the event thing. I have an observable that represents my data source, and I can subscribe to that observable in one or more other locations of my system in an entirely separate way. And it's going to magically take care of all that creation of promises and the bridging the gap for us. So it's a way in programming to represent what we can visually think about, or conceptually think about from a spreadsheet. We can represent each one of those different fields as a different step in a chain of response to an observable. So here's a quick example of some code from RxJS. You'll notice that you create an observable using rx.
You
might be
that
whatever the value is in there times 2. So when I type in 10, then as soon as I hit enter, immediately this field says 20. And I might have another field over here. I might have D13 that says D13 is the calculation of 3 times whatever's in C2. So I change this to 20. C1 becomes 20, C2 becomes 40, and D13 becomes 120, right? Do you see that the calculation chain is a flow of data? We're setting up a flow of data from an original source location to all these different places where we're doing something with that data, we're calculating something, we're subscribing to and responding to that data. That's the genesis of this notion of reactive programming. When we think about reactive programming, it is to say, the source of my data is some event source. But the data, once I get that event, it's going to go through a series of steps. And some of those steps are going to be direct, like responsive, just calculate something. And some of them might be asynchronous steps. The calculation of the data that goes through the spreadsheet as you change one value, even though it looks immediate to us, each step it has to update all the fields and then update all the fields and then update all the fields. So there is some propagation delay, if you will. But we can think about an observable, or rather reactive programming, as a way to model a piece of data coming in one side, that's from the producer, the event emitter, if you will, coming in one side, and all the steps that it takes to propagate its way through a system. It's a data flow mechanism. And data flow mechanisms are built from the ground up to respond to events. So if we've got event-oriented systems, this might be a really good abstraction for us. Does everybody follow where I'm coming from conceptually?
So hey, is this model that I need to have?
So let me boil this down for you.
An observable once I get that from
is
the
an
event
adapter
source, I can
hooked on to an
all
event
of this
source
step and
that
propagate
produces
that
a promise
the
every time a
system.
new event comes through.
All of this step and propagate.
But it does so in that separate way where I can set up my event source, and an entirely different part of my location, I can declaratively say what's my data flow. I don't have to conflate the two like we were doing in those other examples where I put the promise inside of the event thing. I have an observable that represents my data source, and I can subscribe to that observable in one or more other locations of my system in an entirely separate way. And it's going to magically take care of all that creation of promises and bridging the gap for us.
Take this path.
So it's a way in programming to represent what we can visually think about, or conceptually think about from a spreadsheet. We can represent each one of those different fields as a different step in a chain of response to an observable. So here's a quick example of some code from RxJS, you'll notice
By
that
the
you
time they
create
get this
an
data,
observable
I'm
using
going to pass through a series of
rx.observable.fromEvent.
states
That's one of their
and then
many utilities they
propagate that
provide.
to my
And
system.
the way it's set up is it takes a
Oh,
DOM
crap.
element and an event name. It automatically hooks the event name to the DOM element, and every time one of those events fires, it pumps another piece of data through the chain, through the observable. So that's how we create an observable from an event. There's about a dozen or so different ways to make an observable. You can make one by attaching it to an event. You can make a plain old simple observable that you manually are going to pump some data through. You can attach it from, a website. I mean, there's a lot of different ways to make observables. But I make an observable on line 1. In an entirely different part of my system, I can declare what all those steps are, what all the calculations of the fields in my spreadsheet look like. Basically, I make a declarative chain of the data flow. So every time an event comes in from the DOM event, every time I click on a button, that's a piece of data coming in, and it's going to flow through this chain.
Exactly. There's a piece of
Now,
data that
we
is
have
going to capture
utilities that look familiar
here
to
and
us, like
pass
map.
through this.
Map in the synchronous sense went over a whole array of values. Map in the asynchronous event is just invoked every time a new piece of data comes along. So you can actually think about an event stream as a never-ending array. And we can perform the same sorts of list operations across time that we would do all together. That's why it was important for us to understand maps and reduces and things like that. So here we can map over an event stream in much the same way conceptually that we could map over an array that was already complete. It's just that every time a piece of data comes through, we can do some sort of transformation on it. And here the transformation is I'm extracting the class name from the event object. Okay. We can filter down. We can perform an exclusion on our list. And that's something interesting, because fundamentally this list is actually asynchronous. We can actually have steps in our response that are asynchronous. Distinct until changed. It's an interesting one. What it says is, the first time a piece of data comes through, let it go through. But if another one comes through with the same piece of data, don't let that go through because I've already seen that one. But then if something new comes along, let that one through. And if I keep getting the same one of those, don't let any more duplicates come through. So let's say I have one that the number 1 comes through the system, and I get 5 of those. Only the first one's going to be let through, and the next 4 are going to be ignored. And then a 2 comes along. So I'm going to let the first 2 come along, and the number 1 comes through the system. And I get 5 of those. Only the first one's going to be let through, and the next 4 are going to be ignored. And then a 2 comes along. So let's say I have one that the number 1 comes through the system, and I get 5 of those. Only the first one's going to be let through, and the next.
And I fire 5 of them. And I fire 5 of those.
Next 4 are going to be
only the first one was going to take that
ignored. And then a 2 comes along.
Ignore.
So I'm going to let the first 2 come along, and any duplicates are going to be ignored. What happens when another 1 comes along? I'm going to let one more 1 come through, and then ignore any duplicates. That's what the until changed is. So there's distinct, which is just, I only want one ever of the thing, and distinct until changed is distinct, and then I reset every time a new value comes in, I reset what I'm remembering. So you notice in this chain, not all of my events are going to make it to line 11. And that's totally okay, because we're setting ourselves up with a data flow, just like we would in a spreadsheet. Subscribe is kind of like the end of the chain. Subscribe is how you basically have a sort of synchronous response to any events that are coming in. So there's more to it than that. But you notice that basically subscribe is kind of like a synchronous thing. I'm not transforming any data. It's not really going to show up in the middle of my chain probably. It's kind of going to be at the end of my chain. It's when I am finally done with whatever the data is through all of its transformations and filterings, I arrive at some data. So at the end of my chain, I have a subscribe. I have a piece of data that comes in, and I can console.log it out. Okay? So that's a real high-level view of what working with an observable is like. We have to make an observable some way, and we have utilities and libraries that can do that for us, and then we have to respond to observables. And it's appropriate, I think, some people disagree with this, but I think it's appropriate to think of an observable as a stream. It's a stream of data that's going to come through. It's being pumped by a set of events, and it's a stream of data that's coming through. So what about distinct until changed? I actually want you all to pop this up. You have in your slides the link, or you can just type it. I love this website, rxmarbles.com. Let's all take a look at rxmarbles.com. I just get such a kick out of this website. Let me quickly orient you. Go ahead and click down on the distinct until changed, which is just slightly down the list there on the left. Click on the distinct until changed. And you'll notice that it's depicting for us with these marbles, these little bubbles here, kind of exactly what we're talking about. The stuff on the top is the input, and there's only one stream for this. And the stuff on the bottom is the output. And you'll notice what happens as I start to move these marbles around. What happens if I move this 1 over here? You notice how it just disappeared? Because the sequence meant that it was just a duplicate. So we can move the marbles around and see how these different stream operations operate. We're going to come back to RX marbles and look at more stream operations in a little bit, but you can notice that probably about the top, I'd say maybe 30 or 40 of them are depicted here. RX actually has probably like 150, maybe 200 different methods. It's a pretty big library. All told, if you got everything, I think it's something like 150, 200K of JavaScript. So it's a pretty stout library. It takes a while to learn all these things. I have not found any other resource on the web that is better at learning than RX marbles. I think you can probably learn 50% of observables by doing nothing but just playing around with the bubbles on the screen. It's a really fantastic resource, okay? Helps you visualize what's happening with your different stream operations.
Visualization.
So we'll come back to distinct until chain.
Okay, so that'll be all for this video. Take care. Bye-bye.